Hello and welcome. I'm Elizabeth.
And I'm Chong.
And we're here today to use the PASCO Capstone software and talk about the feature of video analysis. So I've already started an experiment in Capstone, and I have two graph displays, and I've imported a movie, and the movie's been pre-recorded, but Chong's going to explain what the movie's about.
So the movie is going to have a ballistic cart on a PASCO pass track, which is bigger than the one that's shown here, moving, and a ball shooting up out of it, and we're going to track the ball.
Okay, so let's see what that movie looks like. I'll go ahead and play it here. There it is.
So I noticed, Elizabeth, that the movie is very slow.
It does appear very slow, almost as if it were a slow motion. Why is that?
And that's because the video was shot using a high-speed camera.
Aha.
And the other thing I noticed is the cart caught the ball.
The cart did catch the ball, you know, and that's why we have this device. This is meant to show the independence of motion in the X and Y direction. And if we are able to perhaps use our video analysis to show that, that would be a great use for this tool.
Okay, so let's look at how do we go about and correcting for the camera being a high-speed camera.
Great idea. We can actually do that. We can open up the properties in here, and we can go into the movie playback
And
menu.
in this case, the video was filmed in 210 frames per second.
So I'll enter 210 here instead of 29.
Okay.
Okay. Now let's play that back and see if that looks different.
Oh, that looks more like real life.
That looks exactly like real life. Exactly.
Perfect.
Now, as Chong said, 210 frames per second, we're going to end up clicking the mouse on the ball to track it. And if we work at 210 frames per second, that's going to be a lot of clicks just to follow that little tiny ball.
So do we have a tool to
We do, in fact, have a tool. We can address that. Let's tell it to advance on each click, let's say 7 frames per second. We'll go into the tool, to the properties, and we'll do the same thing. Actually, before we do that, we need to enter into video analysis mode. So I'll do that. And in video analysis mode now, what I can do is back in the properties, in the overlay menu, I can tell it, instead of advancing every 1 frame per second, for it to advance 7. And so I'm not 17, 7. Okay, so each mouse click will now be equal to 7 frames.
So now that we've corrected for time, is there any way that we could correct for distance?
That's a great idea.
If we wanted our data to be actually usable for real life.
Real world data, yes. So we have here a caliper, and it's draggable, and you'll notice that when I click on either end of it, I can drag it. And the handy thing is, once you tell them about the length of the real track.
So the real track is exactly 1.2 meters. So we actually have something on the screen that we can actually tell how big in video analysis it should be without actually even using a ruler.
Exactly. So I've stretched the calipers to the length of the track. Now all I have to go do is tell it what that length actually is in real world time. So I go into the properties, and on the calibration tool, when I open that up, I'm going to tell it that it's not 100 centimeters long. It is actually 120 centimeters long. Okay, and let me type in 120. All right, so now it's calibrated in both space and time, and I think we're ready to go, huh?
Yes.
Okay, so now it's the ball that we're going to be tracking. So I want to back up the film, the video, until that point where the ball is just about coming out of the cart. There, I would say, and I'll maybe send it back. All right, so I just can barely see the ball coming out of the cart.
And I noticed the ball is quite small.
It's awfully small, Chong.
Help us see better for the see better.
There is. They're called my glasses, so I'll put them on. However, there is also a tool in the tool palette. It's the Magnify, the video in the region of the cursor tool, which is one of my favorites. So what it does is just where I'm hovering the cursor, it actually magnifies that region. So I can just barely see the ball beginning to emerge from the cart, and when I click, it makes the movie active. And now the next click is actually going to lay down a little kind of like digital breadcrumb there. And the next time I click,
So I noticed, Elizabeth, that you accidentally double-clicked 2 points together. Is there a way
did.
for us to go back and correct that?
you know, after we take this, after we finish this up, we can absolutely go back and delete that or correct that point. Okay, now I'm
And as Elizabeth is clicking, I just want to remind everybody, there's actually additional instructions on how to use the additional tools and the video analysis, such as moving the XY graph, changing angles, using radius tools, all hosts of other features available on the PASCO webpage.
all right, I'm almost done with my clicking here because the ball is almost right back into the cart. And there I think it is, and I'm going to give one last click where I know that ball just landed. Okay, and now I'm going to turn off the Magnify tool. And these little clicks that I have done now act exactly like sensor data. So what I have is some data that I could use to populate the graphs. And as we mentioned earlier, Chong, we are curious about whether or not the motion in the X direction and the Y direction really are independent.
Yeah, so we would look for the X velocity versus
Let's look
time
at the X velocity.
and the Y velocity versus time.
Okay, so the X velocity I think is right there.
And it automatically put the time in.
It did actually put the time right there on the Y-axis, and now I'm looking for the Y velocity.
And I noticed that the X velocity is a little bit jagged.
It is pretty jagged, but you know, when I look at the y-axes of both of those plots, they're not the same. On the upper graph, it's a range from about 25 to about 55, and it's not anywhere near that range on the lower graph. So what to do? Well, luckily for us, Capstone has a neat little feature that we can add a similar measurement to this graph, and so I'm going to go ahead and add the X velocity down there. Oh. X velocity. Okay, and there it is.
And now it looks a lot nicer.
It looks, well, at least they're both in the same scale, and that's much better, I think. And I noticed something. What do you think about the slopes of those two plots of data?
They look pretty consistent. They look like it's not the same, but they're consistent.
The slopes aren't the same. They seem to be in great scale, but they're not the same with one another. It looks like the X velocity has a kind of a flat slope, whereas the Y velocity has a decreasing slope.
Yep.
But so they have, wait a minute, that's amazing. They have different slopes, so they had different velocities, and yet the ball still landed back in the cart. What does that tell us?
That the ball was moving the same velocity as the cart in the X direction.
Exactly right. Okay, that's pretty amazing. I'm sure there are all kinds of other things that people would like to be able to do with video analysis, which, as Chong mentioned, there is an instruction on how to do this, and as well as this video available on the PASCO website. We hope you'll go to the PASCO website and look for it, and we invite you to join us another time for another video. Thank you very much.
Yep. Thank you for joining us.